Hello friends, welcome to my channel Cam Solution. Today we will discuss the important topic of class 12 board exams, Chemical Kinetics part 1. So the basics we will discuss, the rate of reactions, and please be with me at the end of the video so I can explain much better. So let's start with the video. Please like and subscribe my channel. First, what do you mean by chemical kinetics? Okay, chemical kinetics is a branch of physical chemistry that deals with the speed of the reaction. The speed of the reaction, what the speed is, how the reaction taking place, is it feasible or not? We will learn about in the chemical kinetics. Okay, there are types of reaction on the basis of speed. Number one is instantaneous rate of reaction, which takes place in the fraction of seconds. Fraction of seconds, example ionic reaction. Okay, next very slow reaction which takes place slowly, example rusting of iron and fermentation. These are slow reaction. We have to speed the moderate rate of reaction in the chemical kinetics, which take place in the 24 hours. Okay, so basically next point is the rate of reaction. How we define rate of reaction is the change in concentration of the reactant, change in concentration of reactant or product with respect to time, how much time is taken. For example, R is giving the product, this is the reactant side and this is the product side. Okay, so rate of reaction, how will we find out, is equal to delta we are using for the change. Okay, minus sign we are using because reactant concentration is decreasing as the reactant is going ahead, upon delta T, which is the change in time. Okay, delta T is the change in time, and this is for the reactant and this is for the product. The sign plus indicates the increase in the concentration of product. Okay, with time. And this graph shows that concentration in time, with time the concentration of reactant is decreasing and with time the concentration of product is increasing. Okay, so change in concentration, we have to find out final concentration minus initial concentration. So R2 minus I1, we have to take on the negative sign, that's why we are taking the negative sign, because the rate of reaction is decreasing. But the rate is always positive as the product is also going positive, so we use negative sign for the reactant. Clear? As the reaction goes further, the concentration of reactant will decrease and the concentration of product will increase. Next, there are two types, instantaneous rate and average rate. Instantaneous, that I have told earlier, that for particular time if we have to find the rate of reaction, we will use instantaneous rate of reaction, any one of the product or reactant. And for the average rate, it is for the long time. You have to write down the reaction for the long reactions, so we use average rate. So we can consider a reaction A plus B is equal to C. This is the reaction A plus B is equal to C. These are the product reactant and the product side. So how will we write the instantaneous rate of reaction? We will use delta here, dx upon dt is equal to minus dA, because this is for the reactant, and upon change in time, this is for the instantaneous reaction for the of the reactant, is equal to minus dB. This is the reactant side, that's why we are taking the minus sign, and here is this, it is the, we will take in the positive sign, dC upon dt. Okay, so this is the instantaneous rate. And for the average rate, we will use the formula delta x. Delta x is equal to delta t divided by delta t, where x is the change in concentration in given time. So this is the example of average rate of reaction. Let me take one more example to understand the concept better. So we will take the reaction 2x plus 3y gives 5z. Now we have to write the rate of average rate of reaction. Okay, average rate of reaction. First we have to write for the reactant. So how we will write? First stoichiometric coefficient half. Okay, delta. This is x upon delta t is equal to minus 1 upon 3 delta y upon delta t, change in time. Okay, for product we are using the sign plus, so 1 upon 5 delta z upon delta t. This will be the average rate, and for instantaneous rate we will use dx upon dt. Okay, so we can use the dx upon dt. This is the stoichiometric coefficient. Clear? Next point, the factors which affect the rate of reaction. Number one, the factor is catalyst. Catalyst, we know it is used to increase the rate of reaction. It speed up the rate of reaction. Okay, so here the graph is given. The minimum amount of energy required by the reactant molecule to participate in the reaction and make the reaction happen, that is known as activation energy. Okay, activation energy. Lower the activation energy, higher will be the rate of reaction. Okay, next factor will be the temperature. You know that by increasing temperature, 10 degree C temperature, the reaction becomes double. Okay, at every 10 degrees Celsius. Pressure, as we increase the pressure, the molecules will collide with each other and the rate of reaction will also increase. And for concentration, if the concentration is more, there is a more collision between the particles because they are more closer, so the rate of reaction of the depend on the concentration of reactant also. You can see here the reactant molecules are less, so they cannot collide and the rate of reaction is low, and here the molecules are more, so rate of reaction will increase by increasing the concentration and helps to move the molecules faster. Next point, rate law. Rate law is the important part. So for this we have taken the reaction, this reaction. Okay, so R is given by the reaction rate, K is rate constant, K is rate constant. This is temperature dependent, it is temperature dependent, and this A and B are the concentration. Okay, these are reactant concentration. We have used this square bracket to show the concentration, and small ABCD are the, what are they? They are the stoichiometric coefficient. Stoichiometric coefficient. And this x and y, this both x and y are the power raised to the power. These represent the order of the reaction. It can be 0, 1, 2, 3. Okay, so rate law can be defined as relationship of the rate of the reaction to the rate constant and the concentration of the reactant raised to some power. This is some power. It can be 1, it can be 2, it can be 3, it can be 0. So according to it, x and y are not the stoichiometric coefficient, they are the order of the reaction. I hope you understand this point. Next we will be moving towards the next point, order of reaction. As we talked earlier, order of the reaction, about the order of the reaction, this is the number of concentration terms that determine the rate of the determine the rate raised to the power. We have done this x and y. If we have taken k is equal to a 1 and b is also 1, then the order will be x plus y it will be 2, then it will be the second order reaction. It can be zero order also, it can be first order also. By addition of this raised to the power, we will get the reaction order. Okay, for zero order, it is independent of the concentration of any reactant. Zero order, it is not dependent. We have because there is no use of the concentration of the reactant, zero, so it is independent of that. In first order, it is dependent on the one concentration of term, and the second order, it is dependent on the concentration of two reacting species. So zero order, first order and second order, you have to study in the 12th class. Okay, next point is reaction mechanism. Molecularity means in one step how many reacting molecules are taking place. So molecularity is defined as number of reactant molecules species in elementary reaction. In first in one step reaction, how many reactant species are taking place, so that will be the molecularity. If one reacting species is there, unimolecular reaction. If two reacting species molecules is there, bimolecular reaction. If three is there, then it is trimolecular step. For this order of the reaction, we have to learn the units. For zero order, the unit will be moleliter S minus 1 first order, S minus 1 second order reaction, L mole minus 1 S minus 1. I hope you like this video. This is very important for the board exams, because board exams are very near to us, and we are preparing for the board exam. And sooner I will back with my next video on chemical kinetics only, the next part of the zero order reactions and first order reaction, how the derivation will be done. So keep supporting and loving my channel, and please like and subscribe, so I can make